Hello everyone. So my name is Lakshay. I welcome you all to the discussion of AIATS Plus Mock Test 9. The paper was conducted on 16th of March 2025. In this paper or in this session, we will be dealing with the organic section of this, or specifically of class 12th. Okay. So the chapters were aldehyde ketones, carboxylic acid, alcohol, phenols, and ethers and amines. Okay. So let us start from the very first question. जय हिंद लक्की, चलो स्टार्ट करते हैं अभी. हाय, हेलो राकेश. चलो लेट अस स्टार्ट फ्रॉम द वेरी फर्स्ट क्वेश्चन ऑफ दिस पेपर. ओके, क्वेश्चन नंबर 50. We have the compound which will show ketoenol tautomerism is. Okay, so this is the very simplest approach. Okay, so before going with the ketoenol tautomerization or something like that, we should know about the fact what is ketoenol tautomerization, what are the compounds which will who will give ketoenol tautomerization, and what is specifically the difference between ketoenol tautomerization and aromatization, and can we say aromatization as a part of ketoenol tautomerization? This is the all points we are gonna discuss in that part. Okay, okay, we will see the explanation or answer to these questions in the meanwhile. Okay, so let us go to the detailed portion of the tautomerization and something called that. Okay, for tautomerization, हमारे पास क्या होना चाहिए? We should be having like a system called having alpha hydrogen is present to ketone, or we can say that, let us take an example of this. This is the enol form. This is the enol form. Let us take an example. This is R group over here. Okay, so what is the point? That the lone pairs, or we can say that any group is present here. Let us take an example called R2 and R3. What is the point? That the lone pairs of the oxygen will migrate itself to this position and move to this, or we can say that this will be in kind of equilibrium. R3, C, R2, we can say that the negative charge will come over here, and C, double bond O, H, positive, and R. And the negative charge formed will directly take in proton. We can say that intramolecular proton transfer will be occur, and you will be having H, C, R3, R2, C, double bond O, and R. So what is the driving force of this enol to go into the keto form? The only one factor which is responsible here to convert this to this. This is the bond energy of carbonyl is way more greater than this position, this groups. So this is the only factor that the driving force to go the enol form to keto form is the bond energy of this CO bond. Despite of having this is the more stable form in these cases. But the only case where the hydrogen bonding occurs, or we can say that the hydrogen bonding part dominates in the position there, the keto, or we can say that enol form will be dominating at that purpose. Okay, so this is the point. So we are having these two positions. This is the keto form, and this is the enol form. Why we are saying that it is a enol? Because it is having the both the groups. The first one is ene group. Can we say that it is an ene group? Yes. And ol means there is a presence of OH. This is ol. So this is the whole background of the ketoenol tautomerization process, and you should be aware about it. Okay. But there is a one case. Let us take an example over here. If you are having kind this. Let us take this. let us take an example over this. Okay, you are having a keto form. Okay, but to the alpha position there is no hydrogen present. So is there any feasibility that it will undergo keto-enol tautomerization? Is there any feasibility here? We can say that there will be no feasibility because there is no alpha hydrogen here. Okay, but there is a case that in keto-enol tautomerization, whenever they ask you, you should be aware that extended keto-enol tautomerization is also a case. How is it case? Because let us say you are having this hydrogen is present at this position. Can this lone pairs will move over here, or we can say that can this bond will move over here, and this pi bond will move here, and the negative charge formed will take a proton and will form. See, this is OH, double bond comes here, there is again a double bond, there is again a double bond. Remember? So we can say that the product formed is aromatic. Or we can say that this keto, always remember, there is a keto group. So we can say that this is keto, and you are getting formed with what? There is one ene which is extra and OH. It means the keto form will move to enol form, and you will be getting an aromatic system, or when we can say that there is a keto-enol tautomerization and it will also yield a product aromatic. We can say that the aromaticity will be occur. And this is the case where enol form is more stable than keto form. Absolutely correct. I hope this point is clear to you all. Is it clear? It means aromatization using the keto-enol tautomerization is also a part. You should be aware and you should consider it. Okay, let's back to the question. What does the question suggest? Okay. Now, let us say you are having this. We can clearly see that there is no alpha position, or we can say that the sp3 hybridized center. Okay, so this can't be the case. Next, as we have already discussed that the hydrogen present here is utilized in formation of enol, and you will be getting the product. It means this is an example of keto-enol tautomerization. Yes. Let us check others. Can it be the case? Obviously not, because the alpha position is having kya? CH3 and CH3. There is no having the hydrogen group for the keto-enol tautomerization. So enol will never be in the case. So this is not a product. Next, can this hydroquinone will be the case? Obviously not, because of not having any kind of sp3 hybridized carbon. Then the class of physical chemistry has already been completed. Please go through the NEET YouTube channel and you will find it. Okay, so the correct answer to this question is option number 2. I hope this is clear to you all. Everyone? Okay, now CH3 is already present here. Let us put it over. Okay, let's move to the next question. Question number 54. Please try to attempt it first, okay? This is one of the most simplest question. Please try and give me the correct answer. And this reaction given, the reaction given here is one of the most important name reaction. Can anyone give me the name of this reaction? Absolutely correct. It means Lucky is kind of doing well, good. Absolutely correct. Rosenmund reaction, absolutely. Wow, Hema Malini is also here. The correct answer is 2, absolutely correct. It means we should not been given that much time out to this reaction, that So the reaction is CH3, C double bond O, Cl. This is acyl chloride, or we can say that aryl halide. And you are reacting with hydrogen in the presence of PD, BaSO4, and you will be getting aldehyde. And the name of this reaction is, absolutely, this is, or we can say that this is not been, charcoal has never been a poison, bhai. Charcoal can never be poison. Barium sulfate can be used as a poison here. So here, the name of this reaction is Rosenmund. So the correct answer to this question is option number 2. All right. Always remember the name of the reaction, bhai. This is the one of the important. Chalo. Let us move to the next concept. We are having question number 61. Wow. It means we have to reduce the nitro. Okay. Let us try to make an entire series of reagent which will be helpful for you to memorize which reagent will reduce nitro to which groups. Shall we? Where the azobenzene is the product, where the aniline is the product, where is the hydroazobenzene is the product, where is azooxybenzene is the product. Shall we? Let us try to make an entire table. It will be very helpful for you guys. Sure. Okay. The first and foremost, you should be aware that the first is, let us consider nitro being a substrate, and we are just changing the reagent and the product of the reaction will be changed. Okay, try to remember it. It will be very helpful for your exam. Okay, the first, if you are taking SnHCl, the product is, can anyone? If you are reacting nitrobenzene with tin in the presence of HCl, what will be the product? The product is aniline. The product is aniline. Absolutely correct. Or if you are reacting with LiAlH4, the product is azobenzene. The product is azobenzene. When you are reacting now, what will be the product of this reaction? Can anyone? हाँ लकी बोलो भाई बताओ. What will be the product of this reaction when zinc dust in the presence of aqueous NaOH is taken? No, you will be getting hydroazobenzene. And if you are changing the solvent, or we can say that if you are reacting with zinc, NaOH, and the solvent you have changed to methanol. Now the product is azobenzene. Always remember, when you are changing the solvent, or we can say that from aqueous medium to a methanol, the product is changed. So we can say that the azobenzene is a major product despite of having that. Now these reactions were not been written in the NCERT, but these were written in your module. But these are kind of somewhat, matlab, lithium aluminum hydride is very much a common question, okay? This can be asked. So please try to remember all these reactions, and it can be useful whenever the case is. Okay, let us try to do one more. What if electrolytic reduction is done in strongly acidic medium? This is the whole set of the reduction of nitrobenzene using the various reagents. It will be definitely helpful for you. Okay. What will be the case? The product is we can say that phenyl hydroxylamine. And it will go to this. This is the major product. This is the major product, by. And if zinc NH4Cl is used, this is the question, na? If zinc in the presence of NH4Cl is used, then the product is simply this. Got the point? And simply if electrolytic reduction is carried out in weak acidic medium, then the product formed is aniline. This is the entire set of reactions of reduction of nitrobenzene. Write down nitro here. Is it clear? This is the entire set of reactions of reduction of nitrobenzene using, we have done from tin in the presence of HCl, lithium aluminum hydride, zinc dust in the presence of aqueous NaOH, or in the presence of methanol, and electrolytic reduction in strongly acidic medium, in weakly acidic medium, and in zinc in the presence of NH4Cl. Is it clear? अरे क्लियर है क्या भाई? Okay. Meanwhile, the one reaction is very much important over here is selective reduction of nitrobenzene, or we can say that, just simply write selective reduction. In this part, let us say you are having a compound like this. And you want a product like this. So what is the reagent you are going to use to convert the reactant A to product B? Lucky has given the perfectly correct answer. You can use either NH4SH or NH4 twice S. Both will give the same product. Absolutely correct. SK has given the correct answer. You too, Lucky. I hope this point is clear to everyone. Is it clear? Let's go back to the question. What does the question suggest? Okay, absolutely correct. NH4 twice S, absolutely. So what does the question suggest? In the presence of lithium aluminum hydride, nitrobenzene will reduce to azobenzene. Many of you will take the aniline, but option 2 must be the correct answer. All right. Okay, let's move to the next question. Should this all in a amines chapter content? Absolutely, matlab, this is a part of amine. Then in NCERT it is not clearly mentioned all the reactions, but you can see the package of the Aakash, you will definitely gonna find it. Sure. Let us move to the next question. Okay. We have question number 63. The reaction of Lucas reagent is fastest with. Okay. Can anyone? What is the Lucas reagent? In which chapter we are going to deal it? 4. Okay. First of all, give me the, this is a discussion class. Okay. You have to give me the explanation. What is Lucas reagent? Can anyone? Okay, absolutely correct. Tanmay has given the correct answer. Okay. The Lucas reagent is HCl in the presence of anhydrous ZnCl2. This is Lucas reagent. This is Lucas reagent. And there is a kind of very special thing about the Lucas reagent is that through this, we're not only going to find that the reagent, or we can say that the compound is having an alcoholic group or not, but through this we can also distinguish either the alcohol is primary, either it is secondary or a tertiary. Okay, so let us try to find it out. Okay, let us say in 3 degree, we can say that, let us say you are having a reaction ROH in the presence of Lucas reagent. I have written like it. You will be having RCl. And what will you find? you will find the turbidity of RCl. You will find the turbidity of RCl. But always remember, there is a case of always a timing. When you dissolve the alcohol in the, or we can say that when you dissolve when you add a Lucas reagent in an alcohol, when the turbidity immediately occurs, we can say that in a fraction of seconds, then you can clearly say that the product is, or we can say that the alcohol is tertiary. When the turbidity is immediately. When? Oh, absolutely. In immediately, or we can say that within a second. Absolutely correct. But when it takes time, or we can say that whether it is a secondary, it will take time. It will take minutes to come into, okay? And the special thing about is 1 degree, it will take a huge time, or we can say that very last time to give the turbidity of this reaction. It is not that last time, it cannot take an hours, or it can take 3 to 4 minutes, 5 minutes to give into the turbidity of this reaction. Okay, the all will produce alkyl chloride, or we can say that RCl. Is it clear? Is it clear? The point related to the Lucas reagent is clear or not? Everyone? We can say that on heating it will produce. Absolutely, you can say. Or we can say that on heating it can produce a turbidity. But if you are not going to heat it, or you will left it for some minutes, it will also give a turbidity. But if you are going to heat it, that will be more convenient to say that it will form a turbidity. Is it clear, everyone? Shall we move to the next part? Okay, first of all, just check the options. This is 1 degree. This is also 1 degree. This is 2 degree. This is 3 degree. So the question is about fastest. It means that 3 degree will yield. 3 degree will yield the fastest turbidity. So option number 4 must be the correct answer. Is it clear, everyone? Is it? Okay. Let us move to the next question, please. We have question number 66. Which among the following will give yellow precipitate with iodine in the presence of NaOH? This is a very important question, guys, and this will definitely gonna ask, and this have comes many times in your NEET examination. This is simply a haloform reaction. This is a haloform reaction. So in these type of questions, you should be aware about the mechanistical approach. Matlab, you have all been heard about it. Always remember the position, like what is the position? You should be having a methyl ketone. You should be having a methyl ketone there in order to carry out this reaction. But this is absolutely not the case. I'm with the help of this question, I'm just giving you many type of other, we can say the other substrate which does not have any kind of methyl ketone group, but they can give the iodoform, or we can say that haloform reactions. Okay, so before going to this question, we have to deal with the mechanical approach. Okay, let us try. Let us see, you are having, let us take an example using the methyl group. Okay, let us see R C double bond O CH3. Okay, and you are reacting with base. Let us take an OH negative here. Okay, so what will be the case? This OH negative, what will it go? This is a basic, and this is the hydrogen over here. It will abstract that proton and will yield R C double bond O CH2 minus, and the negative charge formed is kind of somewhat stabilized with the help of resonance. Now you have added the iodine to it. So on reaction with iodine, this negative will move over here, this will here, and will attack to this and will yield R C double bond O CH2I. This is the first part, mind it A. Okay, let us take another R C double bond O CH2I. Again we have an OH negative. It will abstract the proton from it and it will yield the negative charge formed, and the negative charge will attack to this, and you will be having again H. Mark it B. And on reaction with B, this will move over here, and I negative will be removed from it. R C double bond O C I. This is C. Let us take in C, and after this I'm gonna give you some substrates apart from methyl ketone groups that will also give an haloform reactions. Okay, excited? Excited, guys? None of you did. Okay, let us try to make it. And you are still having OH negative, and you can clearly see that there is not any hydrogen atom left, so that the OH negative will abstract. Okay, so what will be the case here? The OH negative will now attack to this electrophilic center and will form a tetrahedral intermediate. Like this. This is stable. Okay, so what is the case now? And now the negative charge will come back, and you can clearly see that the Ci3 negative is somewhat kind of very much stable. Why is it so? Because of minus M. We can say that the minus M cannot be the case here, because the I negative charge, no, we can say that I negative orbital is too huge that the negative charge will not gonna enter, or we can say that the effect of mesomeric is quite low, but the mesomeric can stabilize Ci3 negative easily. So what will be the case here? R C double bond O OH, and along with it you will be having Ci3 negative. But this is not a correct answer. This is not a correct answer, bhai. This negative charge will abstract a proton from it because this is an acidic proton, and you will be having CH(I3) plus R C double bond OH. So, or we can say that C double bond O minus Na positive. On workup, you will be having this product. Got the point? And this will precipitate out. लकी सर थोड़ा फास्ट करवाइए. जब मैं फास्ट करवाता तो आप बोलते हैं कि स्लो करवाइए. मतलब this is very much important भाई. मतलब I just want to give some time, or we can say that we have to invest some time in such good concepts. Okay, this is very much important. Okay, I hope this point is clear to you all. Now I am just giving you some points. Okay, let us say I have just given you R CH2 C double bond O CH2 I and OH negative. Can I say this reaction is a haloform reaction? Is this a haloform reaction? बताइए भाई. Is this a haloform reaction or not? Can anyone? बताइए भाई. Is this a haloform reaction? Absolutely yes. अब क्यों नहीं बोल रहे हो कि अब ये हेलोफॉर्म है? क्यों नहीं है भाई? Because मतलब you have just crammed it that you should just having a methyl ketone groups, and you have not seen any methyl ketone groups over here, and you simply said no. Is it the point now? This is not the point. This is also why? Because this is the intermediate in the reaction of mechanism we have already gone through. Check B. Is it? Okay, just is this the same? CH2I. Yes. When you gonna मतलब कब आपको ये चीजें पता चलेगी? It will help you. This mechanism will surely help you in order to identify which reaction is haloform, which is not. For this question, I'm just spending that much time, or we can say that we are just investing that much time in the questions. Is it clear, everyone? I just don't want to skip any part or any conceptual part that may mislead you or make may lag you behind. So this is the point. Yes, will give an haloform reaction and will product. Yes. Let us back and check which answer is correct, and then we'll move to the next part. Which among the following will give the yellow precipitate with this? This will surely not been given. This will not. Only this is having the methyl ketone, so this can give. This will also not. So option number 4 is the correct answer. Everyone? Everyone just write the understood portion. Have you guys understood? Okay, let's move to the next question. And again, I'm just thinking about the fact that this is one of the most demanding, or we can say that most famous question of the setters. And this will definitely going to be asked, and that question is very much important, guys. And breaking of ether is that much important that in every paper you're going to see and question from that portion. What is the answer of this? I've told you many times how to attempt it. 3, लो भाई कर दिया मार्क. 4, देख लो भाई. 'Mohit, why? Delete it. Okay. Again 4. ठीक है भाई. Okay, let's try to do this so that the guys who will not been infecting in the class may understood. Let us see CH3, CH3. The person who already knows, try to please revise it. It will surely help you somewhere. You are reacting with HI, only one equivalent you have taken. So what will be the case? The lone pair of this oxygen will attack the proton, and you will be having CH3, CH3, CH3O, H positive, CH3. So what will be the case? There will be the 2 sites at which this bond will be break. The site number A and site number B. And it is clearly evident from the fact that site A will break. Why? Because after breaking of A, you will be having a more stable tertiary carbocation which will gonna form from this, and if you are gonna break from site B, you will be having a methyl carbocation, which is specially, or we can say that we denied the fact that it can't be formed. Okay, so only the breaking will occur from position A, and you will be having CH3, CH3, CH3 positive, and CH3 OH is one of the product. And I negative was already present over here. The I negative will attack, and you will be forming I negative will attack to this. Always remember the direction of bond is from the electron rich species to electron deficient species. None the case, okay? This is the point that the electron rich will always go to attack this position, okay? And you will be having CH3, C, CH3, CH3, I. This is the second product. Okay, I hope this is clear. Everyone? I hope this is clear to you all. So let us check with the answer slides, or we can say that the answers, we have already mentioned that answer 3 is correct. Clear? Wow. बहुत सही. Shall I give you one question regarding it? Amorphous clear? लगता है खाना को ना खा के एकदम बस फोम में है. चलो बहुत सही. Okay, I'm just giving you one question. Please try to attempt it. If I ask you about the fact it's A and it's B. Compare pKa. Yes, बताइए भाई. Which one we can say that which one is more acidic? Can anyone? अब आई ना बात. कहाँ गए अभी ये? मोहित, लक्की, एसके. B is more acidic, okay. So why don't you take in plus I effect of this bulky groups kind of over here? B. Everyone is gonna give the answer B. B is more, okay. So why don't you guys have taken inductive effect of this group? Why don't you? Absolutely correct. This is an example of ortho effect. Can anyone explain it? What is ortho effect? Pankaj sir in the previous session have taken an example of this. Okay, let's try to do it again, okay. Let us say you are having, what do you mean by an acidity? Acidity, what do you mean by acidity? It means, but let us say you are having a weak acid. We can say that HA you have taken. H positive plus A negative. So you when will you say that the product, or we can say that which compound is more acidic? It specifically depends upon the conjugate ion which is formed. If the conjugate ion formed is more stable, we can say that the compound is more acidic. Okay, so we have to say, we have to stabilize this more. We have to stabilize it more. This is the first and the foremost thing you should be aware before dealing with the points such as the acidity of the compounds. Okay, so let us try to move it back. We have this C double bond O OH, and we have taken a bulky group. Okay, we have taken a bulky group over. So what will be the case here? Let us say the groups of this, or we can say that the lone pair or pi electron density will come to it, will come to this position, and will destabilize the negative charge form. Let us say the negative charge is already been formed, and we are just checking either the negative charge here is more stable, or the negative charge formed on the species where the bulky group is not there. So where it is more stable, we are just going to checking over it. So what will be the case? So in this case, when the bulky group is present, what will be the case? The carboxylic or carboxylate ion is not in a plane with this ring. Is not in a plane with this ring. It means the interaction from plane is not been involved in the carboxylate group. It means it is not like this. It will turn like this. Okay, the plane will like this and it will turn like this. It means there will be no kind of resonance from that position. Okay, so this is how it will happen, because of the bulky group present. So if we can say that because of the bulky group, because of the presence of the bulky group, there will be the steric inhibition बोल सकते हैं आप इसको, या फिर we can say that the plane of the compound changes. It means the carboxylate ion formed here is more stabilized as compared to simple benzoic acid. Is it clear? And you will yield the more acidic is this, and pKa of A is greater than B. This is the correct answer. Is it clear, everyone? All well, all well. Okay, everyone, I'm just giving you a question for you homework perspective. Try to attempt it, and please write down in the comment section, please. Let us say you are having, and you are reacting with so what are the products being formed? And what is the name of this reaction? Name of the products and question 3, type of redox reaction. Okay, absolutely correct. Please try to attempt it, and it will be very helpful for you guys. So we will meet you in the next session. Thank you so much for joining this session.